Good day, friends. I'm S. Karthik Shivaram. Through this presentation, I would like to share my knowledge about ultrasonic testing of fields. As you know, the world around us is surrounded with many interesting machines. Many of them are fascinating. So, one of those machines which fascinated me was the ultrasonic flaw detector machine, which I'll be elaborating about through the course of this presentation. So, let's get started. So, before we get into the technicalities of the ultrasonic flaw detector machine, so it's essential for you to know certain basic terminologies like what a disc or a wheel is, what an axle is, what is the material with which a wheel is made, or what is the material with which an axle is made, and how these wheel and axle sets are coupled together or formed together. So as you know, the wheel, of course, all of you must be knowing. So a wheel or disc is that circular portion by means of which the trains move, and this horizontal rod of varying cross section which connects the two wheels is known as the axle. And the material with which the wheel is made is of steel, and it doesn't entirely contain steel. It will contain grades of phosphorus, nickel, chromium, etc. And the grade of steel used for these railway axles is the EA1 grade steel. And you might wonder how they are for how these wheel and axle sets are formed together. Uh, in every coach repairing units present across India, they'll be having a wheel shop where both these wheel and axles will be having separate turning lathes where they'll be turned according to the diameter specified in the RTSO. RTSO stands for Research Design and Standards Organization, which is like the guide manual for the railways. It will be having specifications for wheels and axle diameters, and they'll be turned accordingly. And axle and wheels will be numbered, and they'll be coupled together. So where does it happen? As I told you, it will happen only. It will happen in units where coach repair occurs, and these the three units are the powerhouses of coach repair in India. One is the ICF, which is Integral Coach Factory, present in Perambur in Tamil Nadu. MCF, which is Modern Coach Factory in Raebareli in Uttar Pradesh. And RCF, which is Rail Coach Factory, which is present in Kapurthala and Punjab. All these three factories will be having wheel shops. Of course, when you get a chance to visit this, while entering the wheel shop, make sure that you wear your safety shoes and also personal protective equipments, because the floor might be slippery due to extensive use of grease. So there you'll be finding all this axle and wheels being coupled together, bearings being removed from the wheels, etc. So ultrasonic testing. So before that, what is the reason we test objects? We test objects or products to make sure that they are of the quality which we expect from them. So that too in a sector like railways, where because thousands of people travel every day in trains, so we can't afford to compromise on the quality of the wheels. You see, wheels form the basis of the trains. Because if tomorrow some damage happens to the wheels, then the passenger's life are at risk, and it is the axles which are holding the wheels. Therefore, topmost quality of axle is absolutely necessary for proper functioning of the train. So that's the reason ultrasonic testing is used for testing these axles. So ultrasonic testing is a non-destructive testing. There are two types of testing: destructive testing and non-destructive testing. So destructive testing is that technique where the physical properties of the target materials are disturbed during the course of operation. Non-destructive testing, you are not going to dismantle or you are not going to disturb the object. So the idea of this ultrasonic testing was started way back in the 1930s by Dr. Floyd Firestone from the University of Michigan. So he was the one who sowed the seeds for this technique of ultrasonic testing. So the picture at the top right, which you can see, is that of Mr. Floyd Firestone. So from his ideas, slowly, steadily, scientists developed upon his ideas, and now we have very advanced technology for ultrasonic testing, wherein ultrasonic waves are fired into the target materials, and with any internal cracks are detected. Like they have a very wide range of applications, like checking thickness of body, checking internal defects, checking discontinuities, etc. So coming to ultrasonic testing mission, as you know, receives input and gives an output. So ultrasonic testing missions, there are various ultrasonic testing missions. One of them is ultrasonic fraud detector, which I'll be explaining shortly. Another is the ultrasonic pulse velocity tester. So this mission is used for checking the quality of all these concrete and bricks wherein ultrasonic waves are directed towards the bulk of material of this concrete, and the velocity of the ultrasonic waves is the velocity with which the ultrasonic waves travel in the material of the medium is calculated. In case if there are any defects or any voids are present inside the bricks, then the velocity will reduce. Because if the velocity is high, it means that the brick is perfect and can be used for construction purposes. It's an interesting read. Yeah, you can surf and also enhance your knowledge about this. And axle testing machine is used for testing axles for defects, for not only for it's used for other vehicles bearing it's used for other vehicles bearing trains. Flaw detector is used extensively for AP axles. So coming to the specification of this ultrasonic flaw detection machine. So this was the mission which I saw during my industrial visit. And you see the cost, it varies from about 15,000 to 4,81,000 INR. And the input, of course, the input which we are going to give is the axle metallic body, here is the axle. The output is the waveform which should be seen. And it's one of the biggest advantage of this, that it's a portable. This one is a portable, as it's evident from the picture. It's a portable machine which weighs just about 1.7 kilogram and can be carried from place to place. And the dimensions and the temperature with which temperature and the humidity range with which it operates is also given, and the interface which uses is RS-232. So RS-232 is the interface which is responsible for converting all those electrical signals into into the human interpretable form. As you see, this material, this component probe is the heart of this ultrasonic fraud detection machine. So the function of probe is to direct all those ultrasonic waves into the axle and receive all those reflected signals. And it also plays the role of a transducer. That is, it converts all those discontinuities, the signals generated by the discontinuities into electrical signal, and then it feeds into the interface and software, and the interface of software. And that interface of software will convert all those electrical signals into a human interpretable form, like this in digital form in form of waves. Okay, so coming to the working principle, that is the concept with which the entire ultrasonic testing anywhere operates, is that ultrasonic waves reflect at an interface where the acoustic impedances differ. So I'll try to take out this and explain it to you. As you can see, impedance, you will have been familiar with the term electrical. So impedance basically refers to resistance. So acoustic impedance is the tendency to resist the propagation of ultrasonic waves. So as you can see see this portion and see this portion where the defect is. The tendency with which this portion will allow ultrasonic waves be different from that of this portion. So therefore, there's an acoustic impedance between these two. And you can see the ultrasonic waves are reflecting both. This is the working principle. So ultrasonic waves get reflected wherever there is an difference in acoustic impedance, or wherever there is a crack. And then so this is the working procedure. So firstly, the wheel and axle sets arrive. And then the first duty of the concerned authority who's overlooking this is to note the axle number, and they'll apply grease on the side of axle so as to ensure smooth functioning. And then they'll take this probe, and then they'll just hover it over the surface of axle. As I told you, probe will direct the ultrasonic waves into the axle. And in case and it will receive back the signals, it will convert all those signals will get converted into electrical signals, which in turn will get converted to the form into this waveform. As you can see in this bottom right, in case if there is no defect, there will be two peaks at two extremes of length of axle. In case if there is a peak in between the length of axles from 0 to L, but in case if there is a sudden peak, which means there is a defect, and then the concerned authority will condemn the material of axle. So that's what is being given here as well. The ultrasonic waves are generated from the probe, and signals are converted into digitally interpretable form. Depending on the output waveform on the screen, the axle is adjudged as defective or non-defective. So coming to the uses of this ultrasonic fraud detector machine, it's used for finding the hidden cracks. It's used for detecting discontinuity and for inspecting whether a weld is of good quality or not can be used for that purpose that purposes as well. It's used for forging testing. So one of and coming to advantages of it is that it can detect even cracks of very can detect cracks of very minute proportions. That is biggest advantage of this ultrasonic testing procedure. And also, it's a safe method. So one of the main reasons why I chose this machine was the non-destructive testing is becoming an area of interest for many budding mechanical and production engineers. And I'm myself a mechanical engineer during my undergraduation at Madras Institute of Technology. So in the future, ultrasonic testing or non-destructive testing rather is going to be used it's going to be used extensively. Like it can identify flaws, even which the traditional radiographic testing fails to. So I see this field doing really well in the future. So thank you.